My name is Heather Moreno, and this is my short presentation on Gerard Kuiper. Gerard Kuiper was born December 7th, 1905, and died Christmas Eve of 1973 at the age of 68 in Mexico City, Mexico. He is a multiple award winner. In 1947, Kuiper was awarded the Janssen Medal of the Astronomical Society of France. In 1959, Kuiper won the Henry Norris Russell Lectureship of the American Astronomical Society, and in 1971, Kuiper received the Kepler Gold Medal from the American Association for the Advancement of Science and the Franklin Institute. Gerard Kuiper was born Gerrit Pierre Kuiper to Gerrit, a tailor, and Antje Kuiper in the Netherlands. First of 4 children, his sister Augusta Kuiper was a teacher. Peter and Nicolas were both engineers. Kuiper always had a love of astronomy, encouraged by his father and his grandfather, who bought him a telescope as a child. Kuiper was known for his exceptional eyesight throughout his life, being able to see stars 4 times fainter than the average person, which probably contributed to his love of astronomy. Kuiper was also always exceptionally bright, and he entered Leiden University in 1924 after passing a very strenuous and difficult exam, allowing him to skip high school and enter right in. He graduated with a BSc in 1927 and did his doctoral thesis under Ejnar Hertzsprung, the Danish chemist who created the Hertzsprung-Russell diagram classification system of stars. Kuiper's interest in the origins of the solar system and what ultimately led to his work with circumstellar disks was influenced when he was given a book to review that covered that very topic. Kuiper felt the book was lacking and declared that 50% of the nearest stars to Earth were binary and multiple star systems. This was actually an incredibly controversial view at the time, and Kuiper received flack initially. His 1938 Astrophysical Journal paper about this and white dwarfs as high-mass objects is still regarded as a guideline to this day. In 1935, Kuiper left the Netherlands for Cambridge, Massachusetts to work at the Harvard College Observatory. Some say it was due to a caustic and outspoken attitude about his work and the Netherlands. Later you'll find that Kuiper seems to be followed by having a demanding personality throughout his life. In 1936, he married Sarah Parker Fuller. She would remain by his side up until his death. In 1936, Kuiper transfers to Yerkes Observatory at the University of Chicago. Yerkes is where Kuiper really establishes his research about the origins of the solar system and circumstellar disks. This is arguably the second most important observatory he directs and conducts research at. Kuiper's title is Associate Professor from 1937 to 1943, and then is promoted to Professor in 1943. At Yerkes, he meets and befriends the influential Otto Struve, at the time director, and fellow astronomer Bent Strongum, where they co-author a paper about a F supergiant's atmosphere and ionization. This ends up becoming a foundation in studies on epsilon Augereau systems. Kuiper comes back to Yerkes Observatory in 1947 as director, taking the reins from Struve. Funny enough, Kuiper was too into his own research to really take on students at the time as a professor. He only took 1 student under his wing at the time, Daniel E. Harris III. Harris would eventually get his PhD in 1949. In 1939, Kuiper moves his family to Fort Davis, Texas to join Yerkes faculty at the 82-inch McDonald telescope, located at the University of Texas. At the time, the telescope was the 2nd largest in the world. Kuiper always had a love of telescopes and trying to perfect and improve upon them through the end of his life. At McDonald, Kuiper detects an atmosphere of methane around Titan, one of Saturn's satellites. This is the first time one has ever been detected around a satellite. Kuiper would end up loving McDonald because the telescope would allow him to collect data on stars too faint in the past due to McDonald's power. This is despite the toll living in Fort Davis and being separated from urban life that was being taken upon his family and himself. Kuiper collaborates with American developer Robert J. Cashman to produce a spectrometer in 1946. This is spurred upon learning about German science at the end of World War II, helped along by the U.S. War Department. This spectrometer took images of such things as carbon monoxide on Mars. In 1949, Kuiper was the first to hypothesize about the structure of Jupiter and Saturn's atmospheres using spectroscopic and thermal measurements. This also spurred his thinking about planetary phenomena through cosmochemistry, which is the study of the elements and substances that build the universe. Improvements on spectra observations in visible, infrared, and ultraviolet also improve upon Kuiper's original thoughts about cosmochemistry, so Kuiper still has that legacy going for him now. Kuiper discovered Uranus' fifth satellite and Neptune's second move in 1949. He named them Miranda and Nereid, respectively. By 1950, Kuiper had developed his theory on the origin of the solar system, stating that large-scale gravitational instabilities can occur in a rotating solar nebula, and the material in these can condense because they are able to be shielded against the sun's tidal shears. These condensations then become protoplanets and satellites. The gas that was not condensed was instead pushed out of the nebula by solar winds. It was a basic theory that has since been built upon to include magnetic and electrical fields. Kuiper himself realized there were oddities about his theory that he couldn't fully explain, and he explored such topics about that as the Trojan asteroids and the Earth-Moon pairing in a series of papers from 1950 to 1956. He actually became really interested in studying the moon's surface, believing its topography held information on the early development of other planets and satellites. Using the McDonald telescope, many early results from Kuiper's observations of the moon were put into a series of papers in the Proceedings of the National Academy of Science. Fearing the lack of comprehensive works on the solar system, Kuiper gathered an editorial group to publish a 4-volume encyclopedia set on the physics of the sun, the earth, the stars and comets, and the various other planets. In 1947, Kuiper comes back to Yerkes Observatory as director. In 1949, he and his colleagues announced that the frequency of planetary systems is 1 in 1,000. He revised this to 1 in 100, and then nearly half of the total stars in the galaxy 2 years after this initial announcement. This announcement was also controversial at the time because people thought the number was way too high. He left as director in 1949 and returned again in 1957. Kuiper was not voted to be reappointed by the Yerkes staff as director of the observatory, and he was terminated in January 1960. This is due to rising tensions amongst senior staff, according to faculty that had worked there. They just weren't really getting along with Kuiper. He was told that he was too critical and demanding amongst the staff, and his interest in the solar system as opposed to classical astrophysics disenchanted many members. This would give rise and purpose to his move to the University of Arizona, however. After his termination, Kuiper established the Lunar and Planetary Observatory at the Institute of Atmospheric Physics. It was later moved to the University of Arizona. Kuiper was drawn to the U of A because of the excellency of a variety of scientific disciplines. Kuiper was hoping to gather the best and brightest of each and have this new multidiscipline group work together on understanding the origins of the solar system. Funny enough, many Yerkes staff joined Kuiper because they saw his move as audacious and daring. His hope for a multidiscipline research observatory made many excited to participate in its early years. By the end of 1960, Kuiper and his team had already developed a new spectrometer that could take images 100 times the output of his former collaboration with Cashman. Using the new spectrometer, Kuiper measured isotopic ratios and discovered hot bands of carbon dioxide around Venus. He also verified the low pressure of Mars and detected absorption bands of carbon monoxide in the spectra of the Alpha Orionis, among other discoveries. Riding on his success so early in the LPL, Kuiper established a family of telescopes in the Santa Catalina Mountains, about 12 miles from central Tucson. Its crown jewel, his own 61-inch NASA-funded telescope, was put into use in 1965, and the subsequent high-resolution photographs obtained are regarded as some of the best obtained from ground. Kuiper regularly observed at both McDonald and Kitt Peak Observatory and acted as lead on astronomical ground-based observatory planning committees. Due to his interest in the 13,800-foot Mauna Kea in Hawaii, NASA funded and built a 2.24-meter telescope to act as an infrared observing site. Mauna Kea is now known for having the biggest collection of large telescopes in the world. His love and interest in observing the solar system made him sought after by government programs such as NASA for his expertise to the end of his life. Still interested in what the moon's surface has to say about the early development of the solar system and planets, Kuiper published works between himself and colleagues at Yerkes called the Orthographic Atlas of the Moon in 1960. Kuiper published and edited Communications of the Lunar and Planetary Laboratory in 1962, and he used this journal as a way to communicate his ideas to the astronomical community for 11 years. In 1963, Rectified Lunar Atlas was released, concentrating on lunar basins and sparking interpretive discussions on the history of early lunar impact. Kuiper passed away in Mexico City, Mexico. He was there at the time looking at potential observatory sites with his wife and longtime colleague and friend Fred Whipple. In an ironic twist, his circumstellar disk namesake, the Kuiper Belt, is named so because Kuiper hypothesized that area beyond Neptune held small planets and comets that may have formed in the early history of the solar system. At the time, Kuiper also stated he did not believe the belt was still there. He believed Pluto was much bigger than in reality, and its mass had pushed these objects out of the solar system.